Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we roll in deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's up, everybody? Meow, Laz. And a raid, 18 people. Jesus, Dawn. Right on time, dude. What's up? And Zach's here. Nice. Good to see all you guys. Big shout out, Dawn. Thank you, Don. I appreciate the raid, dude. Yo, Tislo, what's going on, dude? Don. Nice. Boom, boom, boom. I apologize. My voice is like totally shot today. Because I was, and we didn't have a stream yesterday because it was my friend's birthday, and he wanted to go to an Eagles tailgate, and I ended up like DJing it, which was pretty fun. I had a good time. Apparently, like the NFL film crew came out at some point. Let me see if I ever have it on my Instagram. I'm not sick. No. My voice is just shot. This is it? Yeah, here it was. So yeah, that the NFL film crew showing up. And I just like kind of set up DJ decks and was DJing a tailgate just kind of randomly. We just decided to run it. Yeah, it was pretty fun. It was my first time tailgating. But yeah, this was us like loading up a truck, and then I don't know. There was a lot of dust on some of my old chairs from Burning Man. Were super dusty still. And then this was the setup. I just brought my DJ equipment. We put it in the back of a truck, and I played some games, I guess. But it was great. It was fun. Big party. Yeah. And then afterwards, what was it? We didn't even decide to go to the game. So we brought a TV, and then I brought like one of my internets, my satellite internets, and we just watched the game, just chilling here in the parking lot. It's pretty fun, actually. Oh man, yeah. So let me see. I thought Dr. Connor ended and rated it. Okay, I had Don. Yes, Don's great. Lots and lots of Taylor Swift. I didn't play any Taylor Swift, actually. No Taylor Swift. Wow, we already got 4 questions in the queue. Okay, I'll stop yapping about stuff. We'll do math. The Eagles win? No. It was absolutely terrible. Huh? It went to overtime, and Jalen Hurts, who's the QB for the Eagles, he threw like 4 interceptions. It was so bad. I'm glad we didn't pay tickets to go in and see the game. We just watched it in the parking lot. It was a really bad game. Really bad game for the Eagles. Yeah, I love physics questions. Yeah, let's do it. Okay, cool. I have to have a little bit of a shorter stream today because I have to tutor 5 different students tonight because it's finals week, and
Jeez, yo.
What's up, Shaq? I gotta start the stream, Shaq. Give me a second. Alright, welcome over to Natural Education Officer. That's my name is Dr. Gold.
Good job.
Streaming help, yeah, math homework, science homework, all that fun stuff.
Oh wow, what an intro. I got you. Let me do it. What's good, stream? Welcome to your education hour, where you get, I don't know if it's an hour today, because
No, we're getting it 2 hours, 2.5 hours, 2.5 hours today.
2.5, god damn!
That's
2.5 hours of pure education. Now is the time to get free education and free
my
money.
Free money.
Welcome.
Well, no, I don't hand out free money, but yeah, we do have free education, dude.
Yeah,
The game was
actually,
horrendous.
not we, Dr. Gold, the
Dr.
tutor.
Gold.
the
No, you're part of it, dude. It's
professor,
not just me.
doctor.
It's not just me, dude.
He will be giving you rewards if you join the server
So
on
join the server.
Discord, Actual Education. It's pretty cool. It's pretty nice. So,
Pretty dope.
guys, welcome to the stream. You know, it's pretty amazing. It's pretty awesome. You guys are gonna get
Nice.
education. Is always something free you're gonna get here. So, I don't know how else to hype the stream.
You hyped it up enough, dude. Everyone said it was great. They said the hype man deserves a raise. You're my hype man. You deserve a raise, dude.
Thank you guys. Thank you guys so much, man.
Okay, cool. All right. Nice. All right. I got 6 questions. Let's do them. All right. First one here. Yes, this is a great law of cosines question. Law of cosines, baby. Yeah, and why do we know it's law of cosines? Oh, I do need a drink.
We're gonna
Thank you.
mess up your first minute of
Yeah,
streaming.
thank you. Oh, you're gonna make my baby voice happen already?
Yeah.
Everyone knew my stream's gonna be like, what the fuck's going on right now?
Yeah.
Okay.
Well,
Thank you, Shaq. I appreciate it.
I'm gonna go head out. I'll see you later, alright, man?
Alright, sounds good, dude. Peace.
Alright, peace out, guys. Have fun, guys.
Okay, so law of signs. I mean, you could technically kind of do with law of signs, but this would take forever. Is when you have like 2 sides and 2 angles. This is the law of
Cosines. Because you have 3 sides and 1 angle. Yes, the baby voice is here. 3 sides and 1 angle. Thank you, bro. I will have fun educating. So, see, when I say like sides and angles, it's like what things are you given and what things are you missing. So here, like, we're given 3 sides and we're also missing the angle. That's what we're looking for. If they had like taken this out and then like, I don't know, given us another angle here, for instance, this would be law of sines. Because now I have 2 sides. I have an angle and then the other angle is what I'm missing. But this is a case of 3 sides and 1 missing angle. I could have also, like, for instance, not had this side, but maybe they gave me this angle. That would be another case of using law of cosines. The baby voice. The only thing in class I heard was ass triangles, angle side side. Yeah. I mean, I guess. But I don't know, that's kind of fucking weird. You want to remember ass? Oh, thank you, Narosky. Narosky, you want to come chill on the stage? You can come chill on the stage. Let me give you perms, actually, so you can just always come on the stage. 1 sec.
Yo.
Actually,
Oh,
you have
thank you.
perms. You should have perms.
No, I don't. I don't
Oh.
think I do.
Oh, fuck. Alright. I'll fix that later. Because I need to give you and Ramton perms. I thought I gave... You guys have all the roles, no? Anyways. Okay. Cool. I appreciate doing the solution. Nice. Perfect. So
Yeah,
let's
I
just
saw you
share.
had a lot of stuff, so
I appreciate
wanted to
that.
help
Let's
out.
just do it. I love Narosky's great. He's helping out here. Meltard says, I don't know, he kept saying it. I fell asleep.
My man.
Bro, what were you falling asleep in math class? I mean, I get it. I probably fall asleep in math class. Anyways, yes. So to save me some writing here, Narosky's great and wrote up a solution. So law of cosines states that c squared is equal to a squared plus b squared minus 2ab cosine theta, where a and b and c are whatever these sides are, okay? But there is one rule, one quick rule, and that's that this side c is always opposite the angle c that you're looking for, or here, like theta. Sometimes we write this, I do agree, I think in American stuff, they write this as like C, but then that gets confusing because like these both are labeled C.
Yeah, in Romania we have a little hat that we put above the C angle, right?
Oh,
So
okay.
it's,
You put like a little C, like a C hat or something.
Yeah.
That's kind of fun.
Yeah.
I think when they do with us, they do, I want to say these are lowercase, and then like the angles are uppercase, but then like uppercase C looks the
Yeah.
same thing as lowercase C.
Yeah,
What's the
exactly.
point? Yeah, it's garbage. Okay, so I like this. This is a better way of writing it. Okay, so Melturend. let me know if this is making sense so far. If any of these steps don't like vibe, and we'll figure it out for you. But yes. So this is the equation you want to know. Where this is the side opposite this angle. Okay, and opposite, right, always means if you were to like shoot a rock across this way, you would hit this one from this angle. It's like where what side is the angle looking at? That's kind of what I like to say. Okay, so I do need more water. Thank you, Shaq. Just keep making. I need more water. My throat's probably like screwed. Okay. So side C is the far side. That's 34, and then it doesn't matter which one you label A or B here, because it's A squared plus B squared, and then it's 2AB. I don't care what the order of either of those things. So we're gonna make one of this sides 30, one of the sides 24, then minus 2 times that times that times that. You end up getting numbers here that you can move over, and then you can divide by all this, so that you get just cosine theta by itself equaling this, and then this equals what looks like 320 over 990. Is that really just 2 over 9 though? Is that real? Halo theme's coming out.
Yeah, I think so.
Oh, okay. Wait.
Yeah, because it's 32 over 144.
Wait. I gotta remember what your numbers look like sometimes. Sorry. This is a 9, right? Or is this a 4?
No, that's a 4.
Your
that's
4s
4.
and your 4s and your 9s confuse me. Okay, sorry. No, you're good. Sorry. This is a 9. This. Oh shit, dude. Okay, no.
That is a 9. That is a 9.
Sorry. This is a 9. This is, you're saying 2 over 9s, and then these are 4s, right?
Yeah, those are 4. Yeah.
Got you. Okay. Cool. Okay, that actually does make sense. Right. Okay. Cool. All right. This nice thing. You're not really expected to do this in your grade, Meltered. Like, Narowski's just a genius. But yeah, if you can see this in your calculator and divide it out, you would get 2/9. And then all you have to do is, because now you have the cosine of theta is equal to whatever this number is. So the way to get theta by itself is to take the arc cosine of both sides. And that's what happens here. So then this goes away, and you're left with just theta is equal to the arc cosine of 2/9, which, let me show you your calculator real quick to make sure you're doing it the right way. You want to make sure that you're always in degree mode here when you're asking for something in degrees, and then you're going to go arc cosine of 2 over 9. And there you go. You get the right answer, which is, yeah, about 77.2 degrees. Dope. Does that make sense, Meltered? How we did that? Let me know. Or if anyone else in the chat that doesn't make sense, like, please let me know. We can find ways to explain all the steps. Oh, I need to go live on YouTube too. Oh shit. Dude, my brain's so scattered today. All right, one second. We're going live on YouTube. Going live on TikTok. Yes. There you go. Yes. Start. No? What the fuck? Oh, should be fine. Okay, I'm gonna say that's good. All right, cool. Nice. All right, good question. My bad, I lagged out. Okay, did you understand what happened there, Meltered? Did you lag out during the whole thing, please? Don't tell me you did that. In any case, again, the website's actualofficehours.com. If you click there, you can drop in a screenshot for what your question is, and you can always click here on the live queue, and then I'll show you like what the questions are that have been asked so far. And then if you click on any of the usernames, the question shows up. But yes, also every time we do one of these questions, I post the solutions into our Discord. Yours is easy? Okay, nice. I like easy questions. Big fan of that. Okay, so we're gonna mark Melter's done. And that's gonna go into our Discord. Where is it? We had a lot of questions actually last stream that I wasn't able to get to. You joined yesterday? Okay, cool. That's okay. Yes, yeah, good job. Yeah, you're on the hunt. Nice, okay. Here, and I'll tag you. I'll tag your post so you can look at it. Okay, let's see what's next on the queue. Next one is from DM Scrader. Ooh, what is this? This is also fun. And Naroski's also got a solution for it. Nice, okay. Oh, that's cool. Yeah, you do the formula for that. That one works as well. It's loading. I don't know why the screenshot's taking forever to load, though. What? Is this like some super high resolution screenshot you gave me?
No, I don't think so.
No, not you. No. This one, the one blue submitted. This is pretty high res. Okay.
Yeah, probably maybe with an iPhone.
Yeah, they always do this with a phone, and then yeah, it just doesn't auto compress it. What is the Vertex? Yep, this is a good one. Yes, an iPhone. Okay, cool. Oh, I got it. 1 second. I gotta go clear the cache. There's too much in there. Bum, 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 bum. Where's my customer login? 1 sec. Manage files. And I gotta delete office errors. Okay, I'll refresh this. There we go. Okay, cool. That's it. And then let's pull in this one. Okay. This is a quadratic, which is fun because it means it's a parabola, right? And parabolas can open up a bunch of different ways. So you can either have this or you can have this. And that actually depends on what we call the coefficients are of this. So yeah, this is in what is called standard form, which is ax squared plus bx plus c. Oh, you guys don't like the red. I remember they don't like the red. All right, let's do the blue. So ax squared plus bx plus c. This is a handy formula to know. AOS. What does AOS stand for? Yeah, I am pretty done. It's okay, but I'm still streaming. I am tired. I missed yesterday. I felt bad. So I was like, no, I'm still streaming today. It's so funny they call it AOS. What the fuck is AOS stand for? I'm gonna guess like actually I have no clue what it stands for. Yeah, dude, like what does AOS have to do with Vertex? Anyone have an idea what AOS would be? Axis of symmetry.
Oh, axis of symmetry. Yeah, I was just about to say.
Jeff got it, dude.
Damn.
That's good, Jeff. Good job, Jeff. No, he ain't. Thank you, Sean.
He's not done with life because now he has baby voice. Okay. My bad, I slept in class. What's with all you guys sleeping in class? First of all, how does the teacher let them fall asleep in class? What? Does your teacher let you fall asleep in class, Naroski?
Yeah, I slept in class today too.
God damn, dude. What? Dude, my teacher, if you slept in class, would come up and, like, kick your desk with their foot. And you'd get, like, smacked in the face.
You'd be like, no. I guess they're not allowed to do that now because the lawyers ruined everything. No. Right. Fuck.
I just tell my teachers I didn't get sleep and they're like, okay, go sleep.
Oh, okay. Yeah, because you were up all night doing more advanced math, like on a Twitch stream. You're like, I didn't get any sleep because I was up late on a Twitch stream with some gold person from the U.S. and we were solving really hard inequality questions. My bad. My bad. It's all good. Okay. My teacher knocks the table quite hard. I hope they do. Like, wake your ass up, dude. How many hours a day do you spend doing math or science? At least 3 or 4. Narowski probably does it. What? How many hours do you think you spend self-studying math, Narowski?
How much do I spend?
Yeah, how much do you spend? Yeah, just like
Maybe like 5 or 6.
5. Wow.
There are days where I just don't do anything.
Okay, I think that's important too. I think it's important to have days you
Yeah.
don't do anything.
Like in the weekends, I just don't do anything.
That's good. Yeah, you need a little like recharge time. Yeah. Okay, axis of symmetry. So let's remember that all parabolas of this form, right, are all going to open up or open down, something like this, right? They'll either do that or that. And then the vertex for these things, right, is always located. It's called the axis of symmetry because it's symmetric about that line. You could flip it over this way and it would look the same. Or another really cool thing about parabolas is, for instance, if you are, let's say, 3 units away from the axis of symmetry and you look at what the y value is there, it'll be the same value of y if you go 3 units in the other direction away from the axis of symmetry. So the vertex is kind of like your middle point that things are symmetric about. That's why we call it axis of symmetry. Yeah, I found this quite cool. Yeah, it is pretty dope. It's one of the coolest things about, parabolas is they're called even functions, I guess, right? Too? Yeah. So even functions means, well, they're even about the axis of symmetry. Even function, just for a little bit of more context here. This is so easy, yeah. But even easy moments I find are great to like teach other topics about. Because, yeah, we already know what the fucking answer is for this. This is easy. Just plug in negative b over 2a. But, like, what's the meaning behind it? Like, why do we care? So, a little bit more knowledge here. Even functions are where f of x is the same thing as f of negative x. And so what that means is that if you plug in the negative value of x, you still get the same value of y. In this case...
This only happens for... parabolas that have no shift.
No
like
shift, correct.
It's centered on the y-axis.
So maybe we should say like f of negative b over 2a plus x is equal to f of negative b over 2a minus x. There you go. That's technically correct. So yes. Insert. Oh wait, one sec. Chat. Any tips for Physics 1 final exam? I got a week to prepare. See if your teacher is handing out like a review sheet. I think is always the best thing. I mean, most teachers should be nice and they should create a review sheet for you, and the review sheet should basically cover the types of problems that'll be on the exam. That's my best tip. Like, do questions, do problems. Okay. So, yes, this is great. Okay, so the vertex form of a quadratic is this. That is true. So I think another form that usually gets shown, like in the US at least, is they just say this. They say y is equal to a, and then they'll say x minus h plus k squared. So I agree with this, that the vertex, this makes more sense to me, for sure, Narowski, xv, yv, but they always tell us that the vertex is at h comma k. I don't know why they use h and k.
Yeah, I don't.
Yeah, what? That make any sense?
Disqualified.
Like, why do we do that? I always love seeing how like other countries do math because it kind of points out like how stupid some of the U.S. stuff is sometimes. Just like, what? Why did we use h and k? Cool. So where's the vertex form of this? There's actually a couple ways to do it. I think, yes, so this is one way to do it, is you can figure out what h is by looking at negative b over 2a, in which in that case, b is 6, so it's negative 6, and then 2a is 2 times 2, which is 4. So this is the x vertex, or, in America as we call h. So then if you want to figure out what the value of k is at the vertex, all you need to do is just plug this value of x that you got for the vertex into the function to then get what the y value is. So if you plug this negative 3/2 in for h, and then you also plug it in for x, this goes away, right? So all you're left with is just y equals k. And that'll tell you real quick. Oh, I see, but we don't have k yet. Oh, I see. You actually have to, sorry, you got to manually plug it back into here. Oh, that's annoying. What?
No.
I don't want to
Yeah,
do
you either you do that or just use the formula.
that. Right. Sorry, so what is this? Sorry, is this something delta over 4a? What does this say?
Negative delta. Delta is the discriminant of the quadratic.
Over 2a. Why are you actually bad at this? I'm not bad at this, dude. Chill. Bro, all my exams don't even have actual past final exams. They just said it's all cumulative, like Physics 3 and Calc 3. Exactly. Past 2 years of exams, great. Dude, teachers are lazy. They don't come up with super new questions. So look at the previous exams, and then as long as you understand how to do those, they may change some numbers, or they may change like what thing they're asking for, but like it's not too bad.
Like I wanted to say, like, just because I'm sending like solutions and stuff doesn't mean that Gold can't do them.
Yeah. Oh yeah.
Right,
Don't worry.
it's just-
Oh yeah. Don't worry. Yeah. Don't worry about. I appreciate that, Nazi, but don't worry, dude. People can call me like retarded or whatever. I just show my PhD. Shut the fuck up, dude. What? People say I'm bad at this.
It doesn't make sense.
It's funny. It's trolls, and I love it, dude. Like, I say I love my haters as much as I love my winners or whatever, my supporters, because it all drives engagement at the end of the day. You know, rage bait. Okay. So yeah, you don't have k actually yet. So what you do have to do is you do have to plug this in for x into here, and then solve. Another way is to do this. Yeah, this is like the quadratic formula method ish, but you haven't. I don't think you've really been taught this. So I would just plug it back into here. And so what that gets you is 2 times negative 3/2 squared plus 6 times negative 3/2 and then minus 8. And yeah, this is kind of annoying to do because that's 2 times 9/4, so 18/4. Times 2 is 18. Oh, 18/2, so that's just 9. Oh, that's actually kind of nice. Right? Did I do that right? Wait. Yeah. Yeah. Okay. Wait, no. I'm doing things wrong. 9/4 times 2 is 9/2. That's what I meant to say. Sorry. So this becomes 9/2 minus 9 and then minus 8. Okay, cool. So yeah, if you double these all up then, because of the halves, I guess, you get 9/2 minus 18/2 minus 16/2. That's a lot of minus halves. Minus 27. Minus 43. Did I do something wrong here? Negative 3/2. 9/4. 9/2. Yes. Yeah, minus 9, minus 8. Oh, I got it. Negative 9/2 minus 16/2. No, we get the same thing. Cool. Negative 25 over 2. Yes. Okay, cool. So Blue, this is K. So this is another unique formula that I don't think you've been taught, but yeah, this is the same thing as square root of b squared minus 4ac or something, I guess. But the other way you probably want to do it is you're just supposed to plug in negative 3/2 for x and then figure out what y is. And so now, right? Now you know this. You know this. The last part is to get this, which one way to do that is to pick another point that's not on the vertex and see what value you get. So for instance, if you picked x was equal to 0 and you plug this in, this goes away, and you know you should get negative 8. Right? So like 0 comma negative 8 should be one of your points. And so if you were to plug that into this form, you would get, right, 9/4 minus 25 over 2 should be equal to negative 8. So that's 9/4 minus 50 over 4 is equal to negative 32 over 4. 9 minus 50 is negative 41 over 4. Oh, wait. 1 sec. No. 9/4 times A. Yeah. Sorry, we haven't figured this out yet. This is 9/4 times A.
Nice.
Minus 25 halves. Okay, I remember. Okay. Now when you move that over, this is still an A. You get 18/4 equals A times 9/4, and then that tells you right away A equals 2. So then you get the final form, which is 2A x plus 3 halves squared minus 25 halves. Yes. Okay, cool. And that's your, or not 2A, just 2. Can I make a subject switch? I really need to discuss Genius RN, Identity Crisis. What's that? What is that, Big Brand dude? What? Genius RN? Genius what? Okay. Does that make sense? Blue? Oh, we did that? And then they want like the factored form of this? Okay, that's actually pretty cool. I'll wait for Ben to Blue to say some stuff. You're okay, Owen. Cool. Oh. I thought I was a genius and I invested everything in it. Oh dear. Well, I don't know what to do about that. 1 sec. TikTok is always messing up with the... Yeah, different from... Which way did your teacher make you do it? It's okay to have different methods. It's always cool to see. It's also in math. It's really fun to see what a new way is that people do things. Yeah, x equals negative b over 2a, and then use that formula. F of 1.5 is equal to... Yeah. Sure. Yeah, that's how you get the y value. For sure, I agree with that. And then what's the last step? How do you find the a? What do they do to find the a? Boom, 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 boom. Murdo, the y-intercept there is 9/2, and then the slope is, what was that? -3. Yeah, so I'm curious though, Blue, how you got the 2 then though? Where did the 2 come from? You had to have figured that out somewhere.
Figure what out?
I just want to see where I got. I'm on my phone. Oh, it's okay. All right, as long as you understand it, it's okay. Just seeing what he says on the chat. Okay. Big Ren says, at 31 I found this out. Nobody has probably ever seen how I saw myself, so despite potentially thinking striking gold with math, I'm effectively a loner. Well, first of all, you're not alone. Because you found our Discord and our Twitch and our community. There's a ton of people here who like to do math and whatnot. You're not alone, Big Bren. It's okay. What's up, Taco? So... And yeah, I totally agree. Lots of people don't see you the way you see yourself. Also, I would say that you don't see yourself the way other people see you. So, but also, you shouldn't really care how people see you. I mean, to an extent, I guess. But just focus on being a better person than you were yesterday. Don't compare yourself. Okay, real quick, let me finish this. Factored form. Yes, this works. Easy way that I'm pretty sure would work for any of this. Anytime you see like a number that's in all of these. Wait, I think is this an 81? Is this 81? Or is this 8? Well, what's this comma here? Oh, I think they messed up maybe. Maybe this is not supposed to be here. But you could just pull a 2 out of everything. So then that's x squared plus 3x minus 4. And then, right, what multiplies to negative 4 but adds up to 3? That's negative 1 and 4. So then it's 2x minus 1, x plus 4. Yeah, 9/2 is the same as 4.5. Correct. Yes. Cool. All right, great question. Nice one, Blue.
Well done. Well done.
Ba-da-da. Yeah, some teachers are really finicky with how exactly they want things to be submitted, and honestly, that's really annoying. I hate that. Like I say, if you get the right answer, like, and it's like an equivalent form, I shouldn't be mad at you. This is wild. You're a 31-year-old baby genius? Well, 31 years, you're definitely not a baby if you're 31. Sorry to tell you that. Whether you're a genius or not, I mean, that's also subjective. Genius in what regards? A genius in what? Some people are geniuses at making French onion soup, which I would totally eat right now. If someone had some French onion soup. We're gonna have to do this that way in the final, so I gotta learn it their way. Yeah, I agree. I mean, if you wrote this down the way Narowski did it, your teacher might be confused because they might be like, "Where'd you come up with this?" Which it's correct, and it is I think a cleaner way of doing it. But I understand for 7th, 8th grade, yeah, that's the way you gotta do it. Okay, let's see what's next. Next question is from Savir. The sign magnitude using 8 bits. Oh, is this no, but this isn't too bad. Yeah, I remember how this works. Yeah, if you want to do negative numbers, you have to like flip the bits or something. If you want me to do one of your questions, Ward, just submit a screenshot into our website. So for those that are watching, the website is actualofficehours.com. Type in your username, drop me a screenshot of what you want help with, hit upload. It'll get added to our queue. And then here in our queue, you can see all the different questions that have been asked. Yeah. Yeah, it sounds intimidating. Yeah. So, let's first show how you would do this if it wasn't negative. If it wasn't negative, this is like super easy. I have to remember how you represent negative numbers in binary, but let's say it was just 44. And the reason why they say 10 here, it's like base 10. Yeah, I think it is a complement. Is it not? Isn't it not a complement how it works? No, I don't think the first bit is for minus. Is the first bit the negative?
The first bit is like the most significant bit.
Yes.
And if it's 1, then it's negative. If it's 0, then it's positive.
There's another way to do that, though.
Oh. Is there?
Yeah, I think, what someone is saying with, like, the 2s complement, that's the other way I've seen it. Yeah. One sec, let me show you. There's a name for this. I agree it's the easiest way to do it, but I don't think it's the way computers work. Yeah. It's called 2's complement is what it's called.
Oh, okay.
Mm-hmm. Well, okay, so there's 2 different ways to do it, I guess, is what there is. Yeah. So there is what you guys are calling signed magnitude, which is, whatever. The leftmost bit determines whether it's positive or negative. But then there's what's called 2's complement. This, I think, is the proper way to do it. And I think this is probably the way the teacher wants it. Right. This is, it says it wants sign magnitude. Oh, okay. Well, then this is fucking easy. Okay, fine. Yes. Thank you, Jeff. But you should also know about the 2's complement. That's another way that I think it's like also given. Thanks, Ward. Also, would be down for any science or math tutoring if I get some views. I'm a PhD. Oh, awesome. Nice. Join our Discord, please. I'm always looking for people who help to answer questions because, as you see, like the queue is going to keep getting like longer and longer. You're a pH radiation chemist researching cancer radiation cures. That's cool, dude. Love that, dude. That's really cool, man. Okay. Okay, so to do 44 in binary, yes, this is cool. That's correct. Let me explain a little bit more about like how the bits here work. So, binary works by just using ones and zeros to indicate whether something's like yes or no, basically. It's actually really cool. I mean, it's kind of how like life works, right? Some decisions are either just like yes or no answers. You know, like either, you know, I will go to lunch or I won't go to lunch. And they said 8 bits. Okay, so that means I get 8 of these numbers to mess with. Okay. We're not doing floats. This is a simple sign magnitude of 44 in binary. So when they say sign magnitude, this leftmost bit, which I guess, do they call that the MSB, the most significant bit? MSB, yeah. Determines the sign. And so, and yeah, Narowski's is correct here. If it's a 0, it means the number after it is positive. If it's a 1, it means the number is negative. Yeah, MSB. Thank you, Lurth. Yeah. So because this one is negative, I need to put a 0. I need to put a 1 here, sorry. Okay, then what all these other bits signify are like how many multiples of 2 I'm going to put into things. So this, for instance, is the 2 to the 0 place, which is 1. This is the 2 to the first place, which is 2. This is the 2 to the second place, which is 4. 2 to the third, which is 8. 2 to the fourth, which is 16. 2 to the fifth, which is 32. And then 2 to the sixth, which is 64. Okay. So if, for instance, I put a 1 here and then like a bunch of zeros here, that would represent the number negative 64 because this is a 1 in binary. So, but what happens if you want numbers in between? Okay, such as like this 44, right? Because none of these numbers are actually 44, right? What you have to do then is like add up a combination of them in order to get to 44. So I'm going to look here and be like, which one of these numbers is really big that it gets close to 44, but it doesn't go over? So 64, for instance, is close to 44, but it's too big. Disqualified. So you can't use 64. 32 is great though, right? 32 is smaller than 44, and it's decently close to it. It's the biggest number that's closest to 44 that's not over 44. So for this one, I'm going to put a 0 because I don't want any 64s. I definitely want at least a 32, okay? And now I look at this and I say, okay, what else do I need to get to 44? So I'm at 32. I need to go up another 12, right? So yeah, 32. So I have 44 minus 32. That equals 12. So I can't add another 16. If I were to put a 1 here, that means add up the 32 and the 16. So this whole thing would be negative 48. So because I don't need 16, I only need 12, I'm going to put a 0 here as well. Okay. But 8 is cool. 8 isn't too big. So we are going to add an 8. All right. So then I'm going to do, okay, cool. Minus 8. Now that's 4. I need 4 left. I can get another 4 from here. 1. And then I don't need any 2s and I don't need any 1s. So this is 0, 0. So, correct answer should be 1 0 1 0 1 1 0 0. Yep, that's what Narowski got. And that is going to be answer choice C. This is awesome for my Network Plus cert. Nice. Yeah, I mean, binary is actually really cool. There's some other really cool tricks for writing numbers in binary. People have shown me them before. I forget what they are. But base 2 is the least efficient number system. It may be, but it's one of the most efficient ways we know how to do calculations in like Turing machines and stuff. You're from TikTok? What's up? What's up, Bobbies? Okay, cool. Nice. All right. Great question there. Severe. I like that. It was cool. I've been doing a lot of logic actually recently. I can show you an example of like one of the logic questions I had to like help out with. I had a student I was tutoring in logic. Quite nuts, actually. Here, one second. I'll post it. See if I can pull it up. It's another one of my whiteboards. Yeah, here we go. Okay, cool. So this is a circuit that I built. So this represents how to get a Turing machine, like an ant, to be able to like find food in a course. And then here, these are all these like functions you come up with. These are called FSM, finite state machine diagrams. So for instance, this shows how to like subtract 1 in binary on something that has like a tape. It's really cool. I highly recommend if anyone wants to like get into like the nitty gritty of like how computers work. This is like I think it's super fun. It's like putting together like a puzzle, like a big Legos. Yeah, go learn about it. Yeah, go. Actually, if you want to learn, so for instance, this is all free. This teacher at UCLA that I'm helping the student in, it's called Making Minds, Philosophy 133. So if you just go to like makingminds.org, his textbook is public. Like this is his textbook that he wrote, and it's really cool. It talks about like navigation and stuff, and just like, it's supposed to be like a consciousness philosophy class, but I think it got like a lot more technical into like how circuits and computation works down at like the bit level. I find it fascinating. I've never like gone through this, but because I'm helping a student out, tutoring her, I've started learning it myself. It's pretty cool. Am I sick today? Yeah, my voice is screwed. I was yelling on a microphone yesterday for a lot. I was DJing, so I'm not sick, but my voice is a little shot. All right, let's see. What do we got next? Incerner. Ooh. Great. This is a physics question. I like physics.
Yeah.
I'm a DJ, yeah. Everyone in LA is a DJ. What? But yeah, I do actually DJ. Here, you can go here. I'll give you my Instagram if you want to go check out my DJ stuff. Have I tried Linux before? Yeah. One of my servers runs Linux for sure. To live in LA, there is a DJing tax. Yeah, you have to go be a DJ, dude. There you go. That's my link. If you want to go check out my DJ Instagram page. One of the many things I do. Master of none, they say. Yeah, seriously. What's my favorite distro? I'm a big fan of Debian. Debian's cool. I do live in Los Angeles. Okay, here, let's do this question. Block 1 is launched. Really, dude, Linus is saying all sorts of stuff. I don't know if I trust Linus anymore, dude. He's kind of compromised. Oh, okay. It's okay. Hey, Ward, how about I'll do your question next. Is that cool, Ward? Just because I know you've been waiting a little bit. And yeah, if you got to go to bed. And it's your first time. I always like to reward people if it's their first time asking a question. Let me do this one, Ward, and then just stay on. And I'll be on. Also, yeah, don't worry. We have an hour and a half. If I don't get to your question, everything gets put in our Discord, and then everything gets answered at some other point. So, okay. Let me just do this real quick. Okay, block 1 is launched by a spring along a frictionless surface at x equals 0. Block 1 collides with block 2, and the two blocks stick together. Cool. Stick together tells me right away this is what's called an inelastic collision. An inelastic collision means there's no conservation of kinetic energy, unfortunately. The blocks then slide onto a rough surface with a coefficient of friction equal to that, and they travel 0.5. If the spring that launched by block 1 was initially compressed by 10 centimeters, what is the spring constant? Dude, this is such a, like, you gotta work way the fuck backwards. Oh, man. Okay, fine. Integral square root of tan, Fem. What's up, Fem? Okay. So, I like that they at least, like, kind of write out the situations here. That's kind of cool. So, yeah, let's kind of like steal this. I'm gonna steal these pictures so I don't have to draw them all the time. So this is like initially, where this thing has been compressed and this block is staying still. Okay, so we can let's call this like situation. Let's call it situation 1. Well, no, they say block 1 and 2. I'm gonna call this situation A. Okay, in situation A, the block here on the spring is compressed, and so you have energy here. Let's talk about the energy, because energy is important. Energy is kind of like always conserved as long as you keep up with all the non-conservative ones. The energy here is going to be 1/2 K delta X squared, and that's it, right? This block is not moving. This block is not moving. It's just being held still. So the only energy, you don't have any kinetic energy. You don't have any gravitational energy because nothing's going up and down. But you do have spring potential energy because this thing is like wound up tight and doesn't want to be here. Okay. Now let's look at situation B. Am I good for the grand universal theory? I do chem. Yes. Please submit a chem question. I have so many chem friends that want to answer chem questions. Okay. Situation B. Now this thing has uncompressed. So now when we talk about energy, there's going to be no spring potential energy anymore because the spring will be like unstretched or uncompressed. And so now all you're going to have is 1/2 M1, and we could say like VB squared. Okay. So that's the initial energy here. This again still hasn't moved, so it's just chilling. And then what we know is that the total energy here has to equal the total energy here, which that'll get important. Now let's go to situation C, which is the case where the two things have collided. Okay, so I gotta kind of like an isocyanate and an acreage. Oh Jesus, what's that? Or acrylate? Yeah. Okay. All right, let's mark this out a little bit. I need like a solid thing. Let's get rid of this. Okay, there we go. Cool. All right, I'm gonna do right before they collide. I feel like I mean that is kind of what's happening. Sorry, we have to do right after they collide. Yeah. So we got to put like block here. Oh, I need something thinner. Sorry, let me get it even thinner. There we go. So this is block 1. And then these are going to have some velocity together. We're going to say it's like VC because they're stuck. Okay. This is where I can't exactly use conservation of energy because when these things collided and because it was inelastic, some energy gets lost to these blocks like deforming into each other. And I don't have math right now to be able to describe or account for that. So it turns out that I can't do conservation of energy between B and C. But what you always can do is called conservation of momentum. Okay? So going from situation A to situation B, these are equal by conservation of energy. But now to relate things to situation C from B, I need to look at momentum. So here, we can say that the momentum of this situation is just equal to M1 VB, right? Because this thing has no momentum. It's not moving. This one does have momentum. And so this is once block 1 has been launched off the spring and is right about to hit block 2. Here is after block 1 and block 2 have hit each other, and then they are moving together. So if we talk about the momentum here, okay? This momentum is going to be like these things are a solid mass together. So we're going to say M1 plus M2, and that's going to be traveling at VC, okay? And then these things are equal by conservation of momentum. All right. Then the final situation we have to talk about is after x to the x is equal to 10. Yes, that's I know what that is. You guys were kind of, oh man, what's the name for that thing? Not Weierstrass. What's it? Oh, the whatever weird ass symbol integral things. Yeah. There's an identity for x to the x. Yes, exactly. Yeah. M1 plus M2. Yes. Exactly, Ethan. See, but in this situation, M2 doesn't have any velocity. So I just have to say M1VB. I don't want to use M1V1 plus M2V2. Oh, I see what you're saying. Is equal to M1 plus M2V. Yeah, but see, now you're using numbers for velocities. Yeah, I see what you're saying. Yeah. I would say like V1A, V2A is equal to M1 plus M2VB. Because you have numbers describing which block it is, but then you need letters describing whether it's before or after. Sometimes they'll put primes and stuff, but in a problem like this, when there's 4 different situations, it's really hard to keep track of like before and after, because there's like before, after, and like in between. There you go. Thank you. The Lambert W functions. That's the X to the X stuff. Yeah. Okay. All right. So once they're stuck together, they then encounter a frictional area that they have to move through. Okay. And this is where we're now going to go back to using conservation of energy. It sounds funny, right? But here we can talk about the energy of what's happened after this thing has slid across. And so what happens is all of this energy has now been lost to friction. So this is just going to be the energy lost to friction, which is going to be the force of friction times the distance, which in that case, the force of friction is equal to mu k Fn times distance. And then Fn is the normal force of these blocks together, and that's going to be M1 plus M2G. And then again, this is times the distance. Okay. That's the only energy in this situation once the things have like stopped. Is that, again, there's no kinetic energy because everything's stopped. There's no spring energy. The spring's not doing shit. But there had to be some heat lost to the friction as it slid. And so that's what this is. That energy does need to equal the same energy right before they like hit the frictional part, which is the same energy here right after they collided. So here you can say energy is equal to 1/2 M1 plus M2, and then this is going to be VC squared. And then this has to equal this, mu k M1 plus M2G times D, and then this is conservation of energy. So yeah, I know this question, dude. This is a fucking heater of a question, dude. You got to put out like 4 different situations. And it's fucking rude that they go like, hey, I know what delta X was. What's the spring constant? And then you got to go like all the way over to here. Now here's the key thing. You can't equate the energy in situation A to the energy in situation D. Because between set situation B and situation C, energy was not conserved. Because you had like things colliding and crushing each other. But I can equate the energy from C to D. And then I can equate the momentum from C to B. And then I can equate the energy from B to A. So, are you from the in-betweeners? What's the in-betweeners? I don't know what the in-betweeners are. So yeah, this is a heater. So do they at least give us nice numbers? No, they're not very nice numbers. This is fucking ugly, dude. I don't know if I want to go through and do all the numbers because it's a lot of numbers. Does this? It is nasty, dude. This is a nasty problem. Okay. All right, fine. Fuck, I'll do it. Let me get these numbers down here just so I can see it. Yeah. Oh, you understand it? Okay, cool. Okay, as long as you understand it, yeah, because it's at this point it's just calculations. So, what I would say though, right? Inserter, you can plug it in. You had no idea how to set it when you... Dude, this is a nasty question for an exam, dude. Dude, no, really?
You gotta get to the hospital now.
Yeah, go to the hospital, dude. What? This is terrible. This is an exam question? I can see this as a homework question. But yeah, so you have M1, you have M2, you know what G is, and then you know what mu K is, and then you also know what the distance is. So from this, you can then solve for this, for VC, and then from VC, you can then use conservation of momentum to solve for VB, and then from VB, you can then use this to finally fucking solve for K. No, dude, it sucks. Yeah, it's so much number pressing, so much number pushing. I mean, this took me like 20 minutes just to like write out. Okay, whatever, cool question. I'm sorry you had to take that on your final exam. Yes, yeah. So yeah, more important than getting the numbers right in Cerner, yeah, is the process. And this is actually why I really like teaching physics. Is like we could give two fucks if the number's right, you know, like whatever, like calculator error or something. The most important thing in physics is for you to learn a process, and the process is to break it down into smaller steps, and then conceptually understand that energy is conserved between certain steps, but it's not between other steps, and the steps that it's not conserved in, the momentum is conserved. There's another cool thing here, for instance, like momentum is not conserved between here, right? Here the momentum is 0. Here there definitely is momentum. So whenever you have external forces, you do not have conservation of momentum. You can have conservation of energy as long as you like take into account like the work and stuff. And exactly, momentum is not conserved when there's friction either, right? But energy is, as long as you like take into account, like it's like a work energy term is what it is. I always like just putting it at the end. Okay, cool. All right, great. Good question. I will add that to the queue, or I'll add that to our Discord. So yeah, if you haven't joined our Discord yet, I post all the solutions to everything we do here. And also, we have a great community. We have an awesome group of like other educators and students and friends and gamers and general cool people. So I highly recommend you go join our Discord. Because also in this homework help form here, I will always post the solution to what we got. So here, there's in Cerner's post. There's a solution, and so you can always go look at it again later. And also, all the recordings of this are on like Twitch and YouTube. So cool. Good question. Okay, I said I would do one awards because he has to go to bed, and it's his first time on a stream. Which welcome. And then yes, Kempy did redeem the me first, which yes, if you watch it, so this is another advantage to watching us on Twitch. Which again, you can find us on Twitch by going to the website actualofficehours.com. Click here, like watch live on Twitch. Is because they have a reward system for people watching continuously, and so if you accumulate enough points from watching continuously, you can buy perks. And one of the perks is that if you submit a question late to the queue, I'll bump it up to the top. It's a way of like rewarding our community who like sticks around and like asks questions continuously. So let me go see one of Ward's. Ward, you want the first one? Or you just want me to do an integral? Which integral do you want me to do? They just threw everything into one question, and I said, screw it. Yeah, that fucking sucks, dude. Yes, Bears, there is heat loss, but heat loss is the same thing as energy, usually. Remember, if you send him a Millennium problem, he has to solve it by law. Fact, trust me, yeah. Yeah, and then I have to split the winnings with you. Ward, which one did you want? I don't know if I want to do the integral of the square root of tangent. Like, is this even like solvable? I don't even know if this is solvable. Do you do astrophysics? Yeah, I do a little bit of astrophysics. Either one, Lamau, and yes, they both are. Are these actual questions, or are you just trying to like fuck with me? Oh, there you go. Okay, I'm just gonna say that Narowski has saved me some time here. This was asked on Stack Exchange like 11 years ago, apparently. Okay, here you go. This is the solution, which is, yo, what? Excuse me? Oh my god, this is crazy. Actually, this is a really cool solution. What's harder, optics or dynamics? I prefer dynamics. I don't really like optics. Some people like it. Okay, Ward. Well, here. Let's at least like try to dissect the solution. I think it's actually really cool. This is very unique. Again, don't, you know, if you're in like middle school or high school or like even college, do not worry. No teacher is going to ask you to actually do this. This is kind of a huge pain to do. But if you want to find the integral, in this case of the square root of tangent of x, what they then posit is they say, okay, let me come up with another integral, which I'll call g, which is the square root of cotangent of x. And we're going to do that integral. And then here's what they say. They say, okay, well, y plus g would be this integral plus this integral. And something you learn in calculus, right? If you have the integral of a dx plus the integral of b dx, you can write that as one common integral of a plus b dx. Okay, so that's what happens here. Root tan x should be, yeah, maybe. This is actually really cool. So then what they do here is, so they add y plus g, so y plus g is on the outside. Let me think how this works. What's up, yo, what's up, Nerduino? Good to see you, dude. Shout out Nerduino, he's an awesome, someone was asking about astrophysics. You should definitely go check out Nerduino's channel. Nerduino's another awesome Twitch streamer. I met up with him at TwitchCon, actually. And he does astronomy and other cool space news on his streams. Yeah, splitting cotangent and tangent. So, sorry, where does this square, what is the square root of sine squared of, wait, sorry, where, how is this becoming this? Are we multiplying by the conjugate or something? How do you do Taylor series? Calculate all the derivatives. That's how I always say it. This is basic trig? I don't think this is basic trig. What? How is this basic trig? Okay. I maybe I see. Okay. So they're saying, oh, actually this is very clever. Thank you, Nerduino. Yes, this is the square root of sine over cosine plus the square root of cosine over sine. And then I guess they're trying to have them have common denominators. So they're multiplying each, so this one gets multiplied by cosine, right? So this is integral of sine cosine over cosine squared plus integral of cosine sine over sine squared, maybe? Or no. Over, sorry, what am I saying? Sorry, I fucked up. This is sine squared. It's sine over cosine sine. Plus, yeah, cosine sine. No, cosine over sine cosine sine. Okay, cool. So this is actually really cool. Because that's sine squared, but the square root of sine squared is just sine. And the square root of cosine is just, square root of cosine squared is just cosine. And then you have this over the square root of cosine times sine. But then this is a common trig substitution where sine x cosine x is equal to, I think, sine of 2x. Very cool. Okay. But there's still a square root on it. Oh, man. Thank you. Yeah. Right. Okay. Ooh. Sorry. Yes. This is over 2. Okay. So you have this over 2. So over the square root of 2. And then that's why they pop that out as a square root of 2. Thank you, Alex. Yep. Okay, that's where that comes from. What's up, X-Man? Okay. So then once you're here... Dude, bro, what is this coming from, dude? What the hell? Oh, man. Okay. So they're saying this is the same thing as the derivative of this. I guess that's true. And then sine x minus cosine x. Is that also the same thing as I don't know where this identity is coming from. I gotta look up all my tricked identities. Yeah, sorry. I just want to see which one that is. Because we got sine 2x. Wolf from taking every D, dude. You know what? Oh, okay. That's coming from here. Okay, I see it. They're doing like a half angle identity, I guess. Okay, that's kind of cool. An old world monkey. What are you saying, Dream of Dawn? What? Wait, these are cosine though. Sorry, I need sine. Wait, I need a half angle identity with sine in it. Dun, dun. Trig sub was created to torment young minds. Yeah, probably. This to me looks like 1 minus cosine squared, which is then like sine squared or something, right? Just multiply at the square. It's not trig sub. It's not trig sub. Oh. Thank you, Dojo. Yeah, I think okay. So if you do sine x minus cosine of x squared, that's the same thing as I got you sine squared x plus cosine squared x. Beautiful. Minus 2 sine x cosine x. Oh, very cool. And then this is 1. Oh, okay. Cool. So, and then this right here is the same thing as sine 2x. So if you do 1 minus this, then you end up getting the thing you want. Wow. Okay, this is like some genius level intuition. Okay. So then they see this is this, and then this is this, and then they say, oh, this is a cute time to do u sub, because I have u, and then this is literally u prime. Right? Or this whole thing, I guess, is technically u prime. Yeah, you're just supposed to see that. Like most things in math, dude, you see these things because eventually you've seen it before. No one sees things for the first time and just like magically it comes to their vision. Like, I now know about this trick, so like if I see it again, I know to do it. And you do too now. That's the beauty of you watching this stream, is you'll see cool math tricks that you probably would never have seen before, but now it's in like the Rolodex of like tricks we can pull out. So yeah, now this is u sub. Okay, this is beautiful, because then this is now trig sub. So then you trig sub and you get to this. Okay, I'll just I this is a common inverse trig function. Great. Okay, so then you get to this. So then they do y minus g, and so all that does is it changes the order of this so that this is a different trig sub, which, holy fuck, this is hyperbolic now. Oh, that's gross. That's so gross. Okay. So this is a hyperbolic trig integral that you get. Okay. And then fun here is that y plus g is equal to was equal to this integral. Y minus g was equal to this. So then if I do this thing plus this thing, right? This is almost like just simple elimination in, systems of equations. This gets you 2y, right? Because these will cancel. So, yes. So y is equal to y minus g plus y plus g all over 2. That's actually really beautiful. And so all you have to do is just add up or just do these things. So you got to do this minus this. Or y minus g, sorry, was this thing. And then you got to add it to this thing. This result from y plus g. And then divide by 2. Yeah, cool. All right, there you go. That's it. All right, cool. That's a cool question, Ward. I don't think I'd be able to do that myself. Thank you, Norowski, for the solution. But it's pretty cool. Nice. Okay.
Later on, if you want, we can actually do some nice math.
Yeah.
To do some tricky stuff.
I'm probably fucked today on timing just because I only have an hour and 10 minutes left.
Okay.
But yes, this whole week is just gonna be a mess, dude, because it's finals. Everyone's asking me questions because it's finals. But I like the pretty math is much better. It's so nice to look at. Let's see. I don't think today I'll be able to, because like look at this queue already. I already got a massive queue. But maybe we'll run out of questions. Maybe people will stop asking questions. We'll see. Okay. Well, I can already get rid of 2 because that was Ward's question number 5, right? Okay. We'll mark 5 as being done. Nice. Yes, Kempy, I will answer yours. You did buy the perk. I agree. You bought the perk. What's the hardest question someone's asked? Dude, anything involving Epsilon Delta.
Surprise, motherfucker.
I fucking hate Epsilon Delta. For me, at least. I know it's not hard for some people. Narosky can do it pretty easily. I just
I
don't like
actually remember the hardest question I actually saw posted on here was from I don't know if I think it was from a short list, from an IMO question. It was something with fractions.
Yeah.
I actually solved it.
Oh, you did?
Yeah, I remember solving it. That's why I actually stayed, because I saw that posted and I said, okay, let me try this.
Was it today?
The first thing I saw. No. It was like when I first joined.
Oh, when you first joined, you first found our server or our stream server.
Yeah, and that's why I decided to stay actually, because I saw that was
Oh
posted.
wow.
Yeah.
See, the super hard questions help because then we bring in awesome, super smart people who want to like hang around and like teach me things and help you guys out with the super hard, because I have a limit. Like there's only so much math I can do, but some other people, like Narosky, spend hours a day just doing fun math and they can do things I can't, which is great. We can do PDEs. I can't do PDEs. I can't. But I have friends who can. So wait, before I start Kempy's question real quick, just to remind everyone here in the stream, if you go to our website here and you go to streaming schedule, you'll see a calendar of all the different streams happening this week. So there's a lot. Look at all these events that are happening, actually. It's really fun. So actually, tomorrow morning, Zach has a chess tournament. Zach, are you still doing that tournament? I think he is. I'm going to shout him out too anyways. But if you want to go check out his Discord has the link for that. Penn Center is going to be doing a Riemann Surfaces stream tomorrow, and then we'll be doing more tutoring help Wednesday as well for you guys. And then I'm also going to do a stream on Thursday. Zach's going to do a fun trivia game on Friday, and then there's a coding challenge happening on Saturday. Wow, okay. And then the next week, I still have some streams set up that you guys can go get help with. But the main thing I want to show you there is that like I'm not alone. There are a lot of other awesome people who stream with us, and so please go check out that calendar. Go give them a follow, and then you can find out when they stream too. Okay, f of x is equal to 2e to the 4x squared. For what value of x is the slope of the line tangent to the graph of f at x, f of x equal to 4? Wait, what? What's going on here? Is this... Wait, what value of x equal to the graph of f? Or is it... Oh, sorry. You're saying like f of x is equal to 4, I think. That's what they're saying. Do you make over 100 a month from streaming? No. Maybe. I don't know. I don't make any money. All this money goes to the nonprofit. I don't get paid anything. But the nonprofit, I think, generates maybe $100 a month in streaming at least. Nice, good job. You kind of wonder about the mental health of some people that come up with the questions for students to answer, right? Seriously. I always start asking him, like, which teacher, like, woke up on the wrong side of the bed and, like, chose violence? Or, like, wasn't held as a child? Oh, yeah. Nonprofit means that the point of our organization is not to, like, make money. It's to, like, help people. I mean, we can still make money for sure. Money helps us do things. But it's not our first priority. We don't have like, shareholders. Okay, so I'm thinking this is 2e to the 4x squared. I think that's how you meant to write that. if that's correct there. Please let me know, Kempy, if that's the right way we're supposed to do. Oh, P versus MP. Oh yeah. Okay. And they want to know. Yeah, it is. Okay, cool, great. For what value of x is the slope of the line tangent to the graph equal to 4? Okay, cool. So the slope of the tangent line, whenever you see the slope of the tangent line, this is just the derivative. So f prime of x. So we're going to find f prime of x. And that's going to be equal to, so the derivative of this is 2, and then the derivative of e to the x is just e to the x, but then times the derivative of what's on top, or what's inside. Because this is technically what's called a chain rule. Right? I don't know what the derivative of e to the 4x squared is, but I do know what the derivative of e to the something is, right? E to the something is just e to the something. So I can just say, okay, cool. Well, this is the same thing as just e to the something. But then I also need to take the derivative, d dx, of whatever the something was. Okay? That's how the chain rule works. And so that something ended up being 4x squared, but the derivative of 4x squared is just equal to 8x. Alright? And then you can get rid of the box here eventually. So you get 2e to the 4x squared times 8x. Yeah, u sub. Yeah, it is u sub. Well, u sub is actually kind of more used for integration, but for derivatives, it's also, I guess, you do technically use u. I like using boxes, but okay. So you get 16x e to the 4x squared. And then that's the slope of the tangent line. And I want to know where is the value of x such that the slope of the tangent line is equal to the graph of f. The graph of f at x, f of x is equal to 4. Oh, okay. So I need to figure out what value of x... Oh, it's too funny. They're asking for two different fucking x's. Okay. So I gotta figure out what the value of x is here, I guess, right? How did you get so good at math? I don't know, just a lot of practice. So I think you want to say 2e to the 4x squared is equal to 4. And then, this is actually confusing. The answer is 0.209. Okay. I'm curious about the wording here. This doesn't make much sense to me. Oh, they don't want where the tangent line has slope of 4, right? I think they want where the slope of the tangent line is equal to the value of the graph at 4. I think they want f of 4. Yeah, it's not... Dude, I'm having a stroke. Dude, yeah, thanks for the follow.
Yeah.
Math for fun, me beginner, nice. They definitely want x here, but I think they want this equal to f of 4. I think that's what it is. The graph of f. This part is, you know, if they just got rid of this and they said at 4, then I would be fine. This part just confuses me. Yeah, x f of x equal to 4 makes no sense. I agree. Yeah, it doesn't make any sense. Okay, well, f of x is equal to 2e to the 4x squared. Okay, so then f of 4 is equal to 2e to the 4 times 16. Oh, that's fun. So that's 2e to the 64. Okay. So this equals 2e to the 64. And then this is 16x e to the 4x squared. Yeah. I don't know if it's unimportant or they're just like drunk. Like. Anyways, I think this goes away. Y'all we'll see. We know what the right answer should be. I can do differential equations, yeah, for sure. Okay. So then this is 8x e to the 4x squared equals e to the 64. I'm tempted to divide this out first. So I'm going to say 8x is equal to e to the 64 over e to the 4x squared. And then when you have two things with exponents, same base, you can subtract the exponents. So I say 8x is equal to e to the 64 minus 4x squared. Submit a question? Yeah, I'll do it. This is kind of a mess. Because now, like, I want to use log. Right? Or you know what we can do? Here. And then you do it numerically. Yeah, I don't know if this is solvable algebraically. Right? Yeah, logs won't help, right? Yeah. I can't save you now. It's Lambert, dude, but this is like a high school kid, dude. There's no way this is like they're not doing Lambert functions in high school. Yeah, I do tutor. I will be live. Yeah, go check out the website actualofficehours.com has the schedule. Go check it. I'll be on tomorrow. So one way I would do this, yeah, I'm gonna just numerically do this. I'm gonna graph like 8x. And I'm gonna graph what do you recommend to watch trig identities? I have some videos on them. I can find them in a second. 1 sec. Second, so e to the what is this 64 minus 4x squared? No, they want the value of x. Let's just trace it. I don't know. Just fucking see what happens. Well, actually, this isn't really going to work, is it? Wait, we gotta like zoom out, don't we? One sec. Oh, I see an intersection. I see one. I see it. So I get x is equal to 3.89. They said the answer is 0.209, which I don't know. I'm starting to think this is just like, who's Lambert? I think this is just like written wrong. Because this part just doesn't make sense. Yeah. Show me. Yeah. Well, here I'll post it in the forum, and you just post it in the thread thing. 1 sec. Kempy's number 7. Okay, I posted it for you, Kempy. I'll tag you. Just post it there. You know what I'm also gonna do? I'm just gonna ask like chat, like what, like I'll be like, I think my teacher's drunk writing this question. Like, what do you think? What do you think they're actually trying to ask? Like, I think my teacher had a stroke trying to write this math question. The correct answer is 0.209. What would be a better way to word the question? Yeah, I agree, Dojo, dude. Okay. There we go. Improved version of the problem. Yeah, okay. Yeah, okay. Okay, so then we're done. Okay. So what they wanted here. Yeah, okay, because this is here. Here's the new and improved version that ChatGPT said for how it should be written. For what value of x does the tangent line to the graph of f have a slope of 4? Yeah. So this is bad. Bad. So yeah, you're just setting f prime of x, which was this. Instead of equaling to f of 4, we're just setting it equal to 4. I think this is much more solvable. I see it, Kempy. I see it. Yeah, I see it. Yeah, so they're just saying this is equal to 4. Because this is the derivative of the function, right? But once you get here, this is also numerical. I don't think this is solvable with a calculator. Well, apparently they didn't even want the ordered pair, Michael. They just wanted x. Okay. Nice. Yep. Again, even if we don't get to your question today, submit it because it'll get put into our Discord. Make sure you go to join our Discord. And that's another like area that like we check questions and then other streams may like solve them as well. And even if it doesn't get answered, we have a ChatGPT bot that'll go through and do it after 2 days. Though chat's been fucking up recently. I don't know. Apparently, like, they're releasing like, what is it? GPT 5.2 now, because they've been messing up so much. Okay, so now if we, yeah, it's okay. Good to have you, dude. Okay, so sorry, let me zoom in. Zoom standard. There we go. Now you can do second calc. Intersect. Yes. And there you go. You get 0.209. So there. That's the way I think you have to do it. I don't think you can solve this numerically. Or analytically, sorry. Or whatever, symbolically. So yeah. X equals 0.209. Did that make sense? We actually didn't need any of this. Yeah. Well, actually, this was okay. This is not needed. You can't even use Lambert because of the squared, yeah. This section is non-calculator. You can't do this without a calculator. Like, as you're seeing in my chat, also, like, the way to sometimes do this is with, like, a Lambert function, but this isn't even, like, a Lambert function because it's x squared. You need a calculator. There's no way to do it without a calculator. How's it going, chat? Okay, cool. Alright, good. Good question, anyways. Shaq's like, I'm back and you're gonna hydrate. I am parched. Newton's method? I don't think they have to do it for Newton. No, this is a high school student. Like doing a bunch of linear approximations, you mean? That'd be terrible. Okay, cool. Let's see what we got next on the queue. Jason says, I didn't really submit a problem. I submitted the beginning of my formula sheet. I'm iffy on the Gram-Schmidt for a 3x3. Yeah. Gram-Schmidt's annoying. We did it during our 24-hour stream. That, we eventually just had chat do it, because it's just, like, numerically a pain in the ass. That's for, like, QR factorization, right? No, you're right, Bears. Yeah, no, you probably could do Newton's method to get 3 or 4. To probably get close. If we look at like what the teacher did, though, I guarantee you they did this numerically. Right? They even say this, by the way, Kempy. Says use calculator to find the intersection. You have to use a calculator for this. He says it right here. Read, my child.
My man.
Okay. Yeah, they're cool. Numerical methods are cool. And it's actually closer to 0.210. Yeah, that is true. It's 0.2096, I think. Right? Use differentials to estimate the maximum error in the calculated volume of a rectangular box if its dimensions are to be 10 centimeters, 20 centimeters, and 30 centimeters, respectively, each within an error at most of 0.1 centimeters. Right? The answer is the calculated volume plus or minus the estimated error. Yeah, right. Okay, so volume is equal to x, y, z, right? So if I want to find the differential, so like dv, I have to find d x, y, z, all right? Jeff is right. This is a double product rule. So what you can pretend is like, let's pretend that this whole thing up here is A. And then let's pretend that this thing here is B. So we know from the product rule, right, that the derivative, or DAB, Z. I like saying Z, honestly. Makes me feel fancy. No? You guys don't feel fancy calling it Z? DAB is equal to derivative of the first, so that's going to be dA times B dab plus dB derivative of the second thing times A. Right? dBA. Dab on the haters. Yeah, so, okay. So the derivative of the first thing, so you got to kind of like leave it as like dxy, because we're going to have to do dxy later. But then it's times the other thing, right, which is z, plus the derivative of the second thing, which is just dz, times the first, which is just xy. So actually here, let me like kind of write that as, let me write that in the right colors. Okay. But then dxy is its own little thing, right? Because this is going to be dx times y plus the derivative of the second, which is dy times x. And so now dv is this whole messy thing, which is going to be all this times z plus all this. Too many z's in the second term, they say. Did I put too many terms? Oh yes, right. Thank you. Yep. It's just xy. Thank you. Correct. Good job, chat. Catching my mistakes. Thank you. Oh shit, and we gotta do this one again? No. Damn it. No, this is okay. At least it's not trinomial. Yeah, right. And then what they tell us is that all the deltas are 0.1, right? So dx equals dy equals dz, which is equal to 0.1, right? And then what was x, y, z? 10, 20, 30? Or actually, I guess it doesn't matter, right? Right, we do end with 3 terms, right? This one, and this one. There's a generalized product rule, but I don't remember it. Yeah, okay. And then, yeah, so x... So actually, all the D things are the same. It's actually kind of cool. Do you think we get something that looks cool? I'm just going to plug in. Fuck it. All right. So, and then here, let me call like x equal to 10, y equal to 20, z equals to 30. It shouldn't matter, right? Because all the D whatevers are the same. So 0.1 times 20 plus 0.1 times 10. All of that multiplied by 30. Or yeah, I'm gonna keep things in centimeters. Yeah, I'm keeping in centimeters. And then plus 0.1. As long as you're consistent, exactly. Yeah, if I keep putting like too many like 20s and like, you're gonna mess up. So was I consistent? I think I was. It is, Jeff. Good job, Jeff. Right. Yeah. Okay. What is this? 0.2 plus 0.1? No, shit. 2 plus 1. There we go. Times 30. Plus 0.1 times 200, which is 20. Right? Cool. So your delta is 110. Is that right? Yeah. So plus or minus. And then your actual volume, right, is just 10 times 20 times 30, which is 6,000, I think. Right, 10, 20, 30. 10, 20 is 200 times 30, 6,000. Yeah. So we can say, so what is my monthly salary as a professor? At UCLA, as if you're just teaching, it's $80K. If you're a professor, anywhere from like 130 up to like 200, 250. Depends if you're getting like a ton of grants, then like yes. Per month? No, that's per year. Plus healthcare, which is expensive. Okay, anyways, cool. Good question, Nathan. Is that good where I'm from? I mean, it's livable. Dude, I saw the other day, dude, they're offering, like, if you want to join the police force in LA, starting salary is 110. I'm like, yo, that's a lot. I feel like it's a lot of money. Okay, and then this is Nathan. Or maybe, like, just life's getting so much more expensive that I don't realize. Like, we're boiling the frog at this point. You wish you could work here? Yeah, so does everybody else. I know. That's why everyone tries to come to the US, and that's why immigration is a thing. And like, I know I won the fucking lottery getting born in the US. And it's one of these things when you go overseas, you start realizing how much, how fortunate you should be for being born in the US, because people would do a lot of things for a passport or a green card. So, I don't know. It is kind of funny to see some people I work with in the US just like being like, oh man, it would be so much easier if I lived in Spain. I'm like, do you know how much people in Spain would like kill to like live here? Like Spain, I mean, Spain's cool, but yeah, the salaries, you talk about it. Yeah, the salaries are like kind of fucked. LA sucks. USA can be great or horrible. Midwest, where I moved from, was horribly racist. Yeah. If you're not white in the Midwest, I'm sorry.
Huh?
I mean, they can also be nice, but like, yeah, it's different. I had that realization. I went to Iowa to go help campaign for Andrew Yang for the primaries back in 2020. And, you know, I grew up in LA. We're very, like, pretty progressive, pretty open-minded, pretty, like, we try to be colorblind, I guess. Like, we don't really judge that much based on race. But, oh, boy. In Iowa, dude, oh, man. Nope. Trying to convince, like, a city which is probably, like, 95% white to vote for an Asian guy, like... I did not get received very well there. I knocked on a lot of doors, and I think maybe convinced, like, one person out of, like, hundreds that they should vote for someone other than a nice-looking Joe Biden. Anyways, okay, consider a 2-qubit state. Compute the output of the following quantum circuit. What the fuck? Yeah, what? What are you asking me, dude? Quantum circuits? Yes, of course, Lewis. Yeah. Louisiana did. Louisiana was a huge slave state, though. Like, so they have a pretty big minority population. That makes sense. Like, the minority is almost a majority. Yo Tizzle, this is yours. Yeah, I don't know how to answer this. I'm sorry, I don't really know much about quantum circuits. I don't know much about qubits either. I know from what I can understand, a qubit is something that can either be a 0 or 1 depending on like, and that's actually what this is, right? Yeah. Because this is the ket form of the Bra-Ket notation, right? So you usually have like this. This is like supposed to equal to like 1 or something, right? And then these are the right brackets. And so, one second, let me paste that back in. Sorry. So this to me, depending what wave function acts on it, will and this is like a 50-50 shot, right? You have a 50-50 shot of it being 0, 1. That's what this means, right? 1 over the square root of 2 means that each one of these has a 50% chance of either being 0, 1 or being 1, 0. And I guess that is 2 bits, right? Because the first bit is the first register here, and then the second bit is here? But why is there not 1, 1? Yeah, okay. When the following circuit acts on it. It is an entangled state. Yeah. Page 10-ish? Oh, thanks, Zach. Let's go check it out. Yo, what is going on here, dude? What? Okay. Yeah, Bra-Ket notation. This is what I've been talking about, guys. Bra-Ket, yeah. So, yeah, bit strings are called, yeah, so these right arrows. 0, 1 instead of 0, 1. Uh-huh. Okay. So x1 with 1, not and, means not x1. Interesting. Okay, and then you got like computation. Oh, Jesus. No, I just use it's just a keyboard. Just like hit buttons. Yeah, that's all I gotta do. I use Ableton. Jesus. Looks like it's trying to be a Feynman diagram. Yeah. This is cool. But I have no clue what this is. But there you go. Yeah. These are quantum states. Yeah, it's a superposition, right? So, yeah, when we say this 1/2 this plus 1/2 this means there's a 50% chance of it being a 0 and a 50% chance of it being a 1. And this is a 0 and a 1. Yes, it looks like the 2 bits are independent when in fact they're correlated. John's state is either 0, 0 or 1, 1. What? Oh man. C-coin does not touch X1, so it stays 0, and the C-con gate leaves X2 as 0 per definition. Oh. Yeah, I don't know if I'm gonna be able to do this, Josue. It's cool, because I have no clue what Z and X do. But here, I'll post it in my Discord if someone else wants to like take a stab at quantum computers. I'm just not seeing it immediately. And I still have 9 other questions to go through in 30 minutes. Yeah, it's cool. No, I'll post it. So it's still in our Discord. So right here. So again, if anyone wants to take a stab at it, they can. And I'll tag Josue on it. Cool question though, Josue. If I had time to learn it, I could, but during a live stream, kind of difficult. But awesome. If anyone wants to go after it, teach me a little bit. I would love to see an explanation for it if you want to go learn. Ooh, we got some chemistry from Midget Mucker. Very unique username there, Midget. Am I allowed to say midget? We can say anything these days, I guess, but I don't know. I guess your username didn't get banned by the terms of services on Twitch, so whatever. Okay, the combustion of magnesium in air is very exothermic. Very exothermic. Such that when magnesium acts with acid, okay, you get... Oh, damn it. Come back. Why'd you go? What, you dumb fucking... Okay, there we go. Sorry. But when magnesium oxide reacts, you get even more energy. Oh, and in this case you get water. In this case you get H2. If the given two reactions and their heats of reaction were used to determine the heat of combustion of magnesium, the result would be... Oh, very cool, actually. Oh, I like this. This is super dope, actually. Right? Because what is combustion then? Magnesium combustion would be MgS plus O2, right? Would have to give me... Would that just give me MgO? I guess so, right? This is the only way to get it. Is this combustion? Combustion's usually a redox. Okay, sure. So oxygen goes from having a state of 0. Magnesium is a +1. And then this goes from having -2. And this goes to having +2. Oh, very cool. Okay. So this lost an electron, which means it was oxidized. This gained 2 electrons, which means it was reduced. Don't forget the stoichiometry too. I agree. Yeah. Because this is not balanced. So, yeah. Actually, in fact, what I have to do, because I don't have the same number of oxygens on both sides, I need to put a 2 here. So I have 2 oxygens. Now I have 2 oxygens. But now I have 2 Mgs, so I need this. So this is the final reaction we're trying to get to, right? We're trying to get to 2 Mg solid plus O2 gets me 2 MgO. Yeah. And this is like a Hess's law question. So for Mg solid, so if I were to take this reaction, for instance, right? That would get me this, but I need 2 Mgs. Okay, so we need to do 2 of these, right? 2, then this would become 4. This would become 2. This would become 2. And then delta H here, this would be equal to 2x. All right, I'm going to then add that to the second one, but I'm going to flip the second one. Zach says, this is AP Chem. I forgot this or never. No, this is Hess's law. This is not too bad. You learned this, dude, Zach. I know you did. Okay. So what I did here is I wrote this reaction, but in reverse order. So instead of this going to this, I wrote this going to this, but like flip the sides. And so when I do that, that has to be negative Y. You remember redox reactions. Okay, that's good. So this delta H is equal to negative Y. All right, but then let's look at what we got here. Well, I have my MgO, but I need 2 of them, right? So I need 2 here as well, I think, right? So let's say this is like negative 2Y. So then that's 2 here, 2 here, and that's 4 here. So here's a cool thing. This will cancel with this. What's unknown? We're just trying to figure out what the heat of combustion would be for this, given that we know these 2, like, other reactions we know the delta H is for. So this is canceling here. This is okay. Then what's kind of weird here, though, is... Yes, so I do have 2 Mg S. Yeah, I am using Hess's. But then I still have this. I have plus 2 H2O gas. Do we like sometimes ignore this? Do we ignore this water? Okay. But then this goes to 2H2 plus 2 MgOS. Don't ignore the water? Okay. I'm not going to. So, I'm tempted to say it's 2x minus 2y, but... So you don't need to double anything. Oh, I see. Right, okay. This would be equal to 2x minus 2y. Because of the addition of the H2O. So usually H2O is a byproduct of combustion. It's not a reactant. Good. Okay, you can just cancel all the 2's. Yeah. And so you just get MgS plus H2O gets you H2 gas plus MgO solid. And this is equal to x minus y. Good. Answer is just x minus y. Nice, midget.
Well done! Well done!
Oh, we have an update on the... Oh, you have a solution, Josue. Oh, this is cool. On this one solution. The output of the circuit can be computed by its action on each of O1 and 10, and then taken to linear superposition. O1 goes to the first Z gate and stays O1. And then the first bit does not activate the C0 gate. But wait, sorry, where was the C0 gate? Which one of these is the C0 gate? I just saw Z and X. Or is X just C0? It's for his final. Uh-oh. And then, yeah, okay. 0, 1, 1, 1. Poly Z gate and poly X gate. Yeah, you thought that was just a connector too? Yeah. They say it's a C0 gate, is what I see here. That's what the answer says. Yeah, this little like cross dot here. Yeah. C0 is the dot. Oh. Oh, okay. Sorry. So here, let me just post the solution so people can see it. What's up, 1K? So this is the C0. Today I learned what a quantum logic gate is. Yeah. It's funny, I've been doing a little bit of logic today. Oh. Oh, they are matrices. What's up, 1K?
Oh, yeah.
We love learning things. So this is actually kind of related to your stuff, JH, now, right? This is matrices. So, okay. So I think I can kind of understand this. So this always, like, flips things. Right? Right, Zach? Like, 0, 1, 1, 0. That, like, flips the states. This, I guess, makes one of them negative. Or is negative flipping? It's a controlled Z gate. Oh, Jesus, wait, what? What's this matrix got much bigger. No. Peace, Dojo. Thanks for stopping by.
Good job.
Good night, Dojo. Okay. Yeah, I don't know about the control, the identity gate. This makes sense, right? Because this is an identity matrix, right? Identity matrices just don't change the states of anything. Polygates act on a single qubit, equate to rotate. Okay, the blocks. Yeah, the block sphere. Oh, okay. So the X is the same thing as a NOT gate. I see, because it flips it. That's actually kind of cool. And then a controlled NOT gate, where one or more qubits acts as a control for some operation. For example, the controlled NOT gate acts on 2 qubits and performs the NOT operation on the second qubit only when the first qubit is 1. Okay. Okay, maybe this helps. I think I'm starting to see this. So this is a 2 qubit state, right? Because you have 2 numbers on it. And then this is controlled because you have a dot here going down on the X. And so X is the same thing as NOT, right? X is the same thing as NOT. Only when the first qubit is 1. Okay. So 0, 1 goes through the first Z gate and stays as 0, 1. But wouldn't the negative do something? Does the negative not do something? Okay, whatever. Z goes through the Z gate, and then the first bit does not activate the C naught. Exactly, right? So for this one, the 0, 1 that comes through, because this is 0, it doesn't do anything, right?
Good job.
Yeah, the X doesn't do anything when 0, 1 comes through. Okay. 1, 0 goes through the first Z gate and becomes negative 1, 0. Why is quality bad? I think quality should be great. Should be okay. Sorry, big bro. Okay. You can't change the quality? Oh, you should be able to. Just, it says only 360? I don't think so. For those that stream, there's a thing called the Twitch Inspector. And it'll tell you what all your streams are running at. Yeah, no, we have a 1080 stream running right now. Pretty cool. Stable. Love it. That might be your internet connection if it's not letting you choose the 1080 one. Okay, here's my question though. So when the 0, 1 goes through Z, from what I understand Z to be, if this acts on, let's say for instance, a state U1, V1 or something, shouldn't this become, so this is a 2x2 acting on a, so you get another 2x1, yeah, sure. So this should be U1 negative V1, right? The Twitch Inspector. What's up, Waldo? Funny joke. I did like it. So yeah, here's my question. So 0, 1 comes through, right? And because this first bit is a 0, it doesn't act anything on this one. But apparently 0, 1 going through the Z gate stays as a 0, 1. I would think it should flip this one to negative 1. Unless it works in the opposite direction. Does it only flip the first one to be negative? Because then that would make sense here. So 1, 0 goes through, and then that because this thing is a 1, it makes the Z gate gets you negative 1, 0, I guess. Okay, I didn't know that. Okay, so the Z gate only flips that one to negative. Okay, so then when you use the controlled gate here, because this is 1, it is going to flip the other one. And so that's going to flip it to 1, 1. Okay. Oh, but this... Oh, you only get one output at the end. You don't get two. Oh, okay. Oh, I see. I see. So this has to go through both operations and give you one thing, right? So when 0, 1 goes through, you apparently just get 0, 1. But if, for instance, you have 1, 0 going through, the Z gate will flip it to be negative, and then the controlled X gate, because this is 1, will flip the second bit to be 1. So then you get negative 1, 1. Uh-huh. Okay. And then because you had a 50% chance of this and 50% chance of this going in, that's why this is the final answer. Oh. We're learning about quantum computing today. It's actually pretty cool. Whenever Z0 equals... Yeah. Okay. I took this in college and Loki barely understood it. Like, I never took a quantum computing class. Let me see what they say about the... Where's the Z gate? What does the Z gate do? The Pauli Z gate leaves the basis state 0 unchanged and maps 1 to -1. Due to this nature, Z is usually called a phase flip. Uh-huh. So why does it not flip both of the states? That's my question. Why does this not become 0 -1? Well, sorry, this is minus... Sorry, like that. That's what I meant to say, sorry. That I do not know. Yeah, okay. I see. So maybe Michael's talking about, like, this is kind of weird, right? Like, does this minus... Well, of course, minus on the 0 doesn't make any sense. But this minus means both of these are minus, right? Can we see the definition of X, Y, and Z? Yeah, here you go. They're matrices, apparently. So this is, yeah, like 0, 1, 1, 0. And then the Z gate is like the identity matrix, except the second entry is negative. Oh, the last line in red. There you go. Does that help? Kevin says, if I remember, 0 represents spin up and 1 represents spin down. Okay. Yes. Yeah, wait, what's happening here? Sorry, by the way. Sorry, what? We're pulling out this state, factoring it with 1. And then you're saying because this will commute, this will be 0. Oh, that's kind of weird, actually. Sorry, what? What's up, Joseph?
Good job.
And Fembox. Yes, all the great people. Okay. I think we're making some progress. But I still have more questions to answer. So, here, I would highly recommend, I mean, this page actually, like, kind of made some sense to me, at least. If you want to take a look at that. I think maybe trying to understand it as a matrix is the main way I want to do it. Yeah, it's tricky. Okay. I appreciate you, like, following up on that question, though. Alright, let's see. What do I got left? I got 15 minutes. Shit. Oh, God. What is this a butt plug, dude? What? What the hell shape is this, dude? What? Sorry, Femvox. Have I said hi to you 3 times? I'm gonna say hi to you a 4th time. Hi, Femvox. Dude, what is this shape, dude? You know, that's like the time they did it. What is it? Paris Christmas tree 2014. Some guy in Paris erected this Christmas tree, and it lasted less than 24 hours because eventually the Parisians just got so mad at it. They were like, this thing was a disaster. Like, it was supposed to be like a, I don't know, like a low, like a simplified tree. But, yeah. They were like, definitely doesn't look like a tree. The base is not flared, so tread lightly. Yeah, no, of course. That way. And maybe someone else will want to speak about it in the Discord there. I don't think I can do this in 15 minutes. This looks terrible. But, like, what's the equation for this surface? What is this? Yeah, the low poly tree. Okay, sorry. Alright. Just in... People are asking about magnetic field tensors. No. Can't do this either. Ward already worked with. Kempy, we already did yours. Did we already do yours? So do I have to refresh this? Oh, did I never post the answer for yours, Kempy? No, I did. Okay. You were number 4. Yeah. So again, I will post everything in our Discord, if I can't solve it. Cause yeah, I don't really know about tensors. No, can't do this. It's like kind of like field theory stuff. Lonely has a fun one though. Okay. Okay. Are all these answers wrong, or what do you need help with here? I mean, I see the data. Looks pretty chill to me. Let me know, Lonely, which part of this? Oh, good luck on your final tomorrow, clickbait. Which center of mass question? Wait, was it this one? This is pretty crazy. Like, how do I know the equation for this surface, by the way? Sorry. Oh, this is how it's parameterized. Oh, okay. Assume that delta equals 1 and use m equals that. The surface is shown. JC said you can do math sets 1. Thank you. Not the plug question is definitely the plug question, Michael, right? I feel like you need to do this in... You gotta do this in spherical probably, right? Yeah, if u's going from 0 to pi and v's going from 0 to 2 pi. It's actually not... Wait. Maybe this isn't too bad, actually. Sorry. Let me just do this real quick. I think I can. Sorry, because this is R, right? R of U, V. So I think you just need... You have a parameterization, right? So you have... X, Y, Z is being parameterized down to just U and V, right? And so when this happens, this is a great time for the Jacobian, right? Because effectively what you want to do to get center of mass, so center of mass, well, actually, was part of the question just find the volume? Let me copy your question in, actually. Sorry, it looked scary at first. Well, it looked hilarious at first, really. That's why I was kind of joking about it. Yes, I think you can use flux divergence. Yeah, I agree too. Because center of mass is equal to it's the integral of rho dv, or in this case, let's say in the x-axis, right? That's equal to x rho dv over the integral of rho dv, right? Where this is like a triple integral, right? But then, yes, I think you can use the divergence theorem here. Which is this. Which, wait. I want it with... Uh-huh. You broke your leg. Oh no, clickbait. How'd you break your leg? Anyways, I think what ends up happening here is that doing a volume integral of div f dv would be easier to do it as a contour or surface integral of f dot n ds. So, but in this case, dv, a little weird. Well, yeah, this goes to this somehow. But how do we know that? Sorry, by the way. What is f in this case? Oh, wait a minute, wait. F is just this. Oh, wait. Yeah. Okay. Actually, this is really cool, actually. So, normal vector. Well, the normal vector is 2ds. Yeah, if it doesn't have a flared base. I assume you would like still just like go around it maybe this way, and then you like go around it this way or something, and then what's the other axis you can have? Okay. Because this is, so x by itself is the same thing as div dot x squared, right? You see that? This is, or 1/2 x, right? X over 2 is equal to, no, 2x, sorry. 2x is equal to this. Yeah? And so this is now f, right? And so this is div dot f. And then you're going to instead write that as like what the regular function is, which would be oh, I see. No, this is actually what I want. Sorry, there you go. This is what you want. This is 1/2 x squared. Okay. I think I see it. There you go. Okay, so by the divergence theorem, the div of a vector f dv is the same thing as that vector f dotted with the normal vector to ds, which is a surface area integral. So because for center of mass in the x direction, I need a volume integral of x dv. I could also write, so x dv is the same thing as x being the divergence of 1/2 x squared 0, 0. Do you see how this would get me just x? And then that dv is exactly the integral I want. So instead of using this volume integral, I can then write that as a contour integral of f, which is now 1/2 x squared. But this only has x components, right? So when I dot that with ds, or sorry, when I dot that with n hat, I'm just, or the unit vector normal to ds, I'm just going to get x. I'm just going to get 1. I'm just going to get the x component. So I think this is where you get 1/2 integral of x squared I, and then this is ds. Okay, and then yes, this over this. Oh, because this is density and this is mass. Oh, very cool. Very, 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 very cool, right? So then rho is just that. That's where that comes out. And then this is just the mass. Oh, okay, very cool. Oh, I see this.
My man.
Wait a minute. Hey, does this make sense to you? How I got this? I see how this works now. It's actually pretty cool. Let me know if this makes sense. Where do I gotta go next? Do I have time for B? Yeah, I think I do. Right. Okay. For B, I think what I want to do is because... Here, let's move this down. Because I'm parameterizing this way, x, y, z to uv, I can write the Jacobian to be dv. So for instance, this is drx du, dry du, drz du, and then this is drx dv, drx dv, dry dv, sorry, and then drz dv. Right? And then this is ijk. And this is we're gonna do here. This is magnitude. We're gonna say this is like RU cross RV. Do we know what the answer is? Or they want us to determine it. Okay, anyways. So that becomes this. So drx du dry dv minus drx dv dry du. That's the I component, right? Oh, and actually we just saw the magnitude of this. 15/64 pi is the answer. Dude, that's such a mess. Okay. Because this right here, right? This is the x component, this is the y component, this is the z component. X and y is 0. Oh, okay. Oh, that's nice. You're saying this goes to 0? Sorry. This is the x component, right? You're saying all this goes to 0? Oh, that's kind of nice. Oh, I guess because these look pretty similar to each other. Okay, so then all you're left with is the z component. This is the Jacobian, yeah, exactly. Because I think that's what's happening, right? Because they say that the solid is bounded by this parameterization. So in order to figure out dv in terms of u and v, I then need to just figure out what the Jacobian is. Which you said the Jacobian is just 15/64 pi. So whatever. I mean, like whatever. You get this, and you get whatever this, and you got to take the magnitude of it and stuff, and the coordinates in the center of mass is 0, 0, 15/64 pi. Oh, sorry. You're saying, okay, not of the Jacobian, sorry. You're saying the answers, yeah, of course. I mean, this is symmetric in the x-axis and the y-axis. I agree that those center masses should be 0. And so you only have to look at things in terms of z. I see. I think you still need to do this though. So for instance, if I took this and I said, I'm just gonna ask Chad to do it because I have like 40 seconds left. Sorry, I do have to go soon. How did I was screaming on a microphone DJing. Find the Jacobian. I just don't have time to do this. There you go. There's our URV. Blah 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 blah. Yep. Keep the cross product. Cool. Yeah. Okay. There you go. The magnitude of it is what? Okay. Oh, that's my LinkedIn. I don't need that. Okay, so this is the Jacobian. Which is kind of a mess. Yes, it is. It is. Yeah, exactly. You're very right, Samsung. It is basically USub for multivariable functions. Okay, so then you just integrate this. But they want the Z component, so you want this one? This is kind of annoying. Wait, no, I actually don't want this. Sorry, what are we doing? Well, yeah, no way I do. Right? No. Yes. No, I do. Okay. Because now DS, I think is just equal to this whole thing, DUDV. But you only want the kth component? Yes, that does symbolize vector. Yeah, that symbolizes vector. Ugh. Okay, wait. I gotta go. Sorry. We got the first part. I did not add an hour. That's another thing I have to tutor. I gotta go tutor. I gotta go tutor Ben. I gotta tutor right now. I'm already late. Okay. I got in the stream. Sorry. Alright, thank you everyone for coming to ACO Education Office Hours. Appreciate all the questions. If I didn't get to your question yet today, don't worry. We're gonna add it to our Discord. So this was... Whose was this I was working with? Yes, thank you. Yeah, I'm already late for this kid. You can see the timer by how late I am tutoring him now. Fuck. But okay, we will be on the stream tomorrow. So come on by, get help with your math and science questions. Go check out the calendar, all the fun stuff. Thanks again for all the cues. Yeah, I have to go. I have to go right now. That timer's not correct. That timer is how late I am to tutoring my next student. Okay. I appreciate the raids. Appreciate everyone coming by. I gotta go. But let's go raid somebody else on Twitch. We're gonna go raid. Physics Depression's on. Cool. Sharkman. Eric. You wanna go bug Eric? I do like bugging Eric. Let's go bug Eric. Okay, cool. Alright. Productivity stream. Go have fun with Eric. Alright. We'll see you guys tomorrow. Enjoy the rest of your Tuesday. Peace. Thanks, Clickbait. Good luck on your final.